Okay, we're still in section 6.4 doing compound inequalities, and this time we're going to be doing problems that will have the word or in between them. So or problems are also known as union, and union means all. So if we look at it with the Venn diagram, union would mean, and or would mean, we want everything from the first set and everything from the second set. So we're just combining all of it together for union. So when we're graphing, let's start with y is greater than 9. Oh, sorry, let me change that. Y is greater than 12, or y is less than 9. So we're going to graph each one on the number line again. Y is greater than 12. Here's 0. Here's 12. Open circle and to the right. Y is less than 9. Open circle and to the left. But in our final answer, we're going to have everything from both number lines on the final graph. So I've got an open circle on 12 and to the right. I've got an open circle on 9 and to the left. And we write our answer basically the same way it is up here with the word or in it. X where x is greater than 12, or, I'm sorry, we were using y. Y where y is greater than 12 or y is less than 9. Now let me do a similar one where we actually have to solve. So I'm on page 341, number 9. So these are all going to have the word or in between it. Or problems will always say or. N minus 7 is less than or equal to negative 5, or n minus 7 is greater than or equal to 1. Always will have the word or. We solve each part. Add 7. N is less than or equal to 2. Add 7. N is greater than or equal to 8. We graph each one. 0, 2, less than or equal to, so I'm going to have a filled in circle to the left. 0, 8, greater than or equal to, filled in circle to the right. Both go on my final number line. So 2 filled in, left, 8 filled in, right, and my answer will be n where n is less than or equal to 2, or, we'll say this in the middle, n is greater than or equal to 8. So once again, or we'll say or, we're graphing everything, we'll write our statements, usually writing two things. But it's not always going to go in opposite directions like this. So I'm now going to do on page 341, this is example 4. And it's a much longer problem. It starts out 3h plus 4 is less than 19, or problems will always say or, 7h minus 3 greater than 18. I'll start by solving the left. Subtract 4, negative 3h less than 15. Divide both sides by negative 3, and there's a red flag problem. So it comes out h greater than negative 5. Had to change the direction. The other one, I'm going to add 3, 7h greater than 21, divide by 7, h greater than 3. I'm going to graph each one, but I'm noticing they're both going to the right. So I have 0, -5, open circle, greater than, to the right. 0, 3, open circle, greater than, also to the right. So, or means everything. Everything from the top one, everything from the other one. Or is also going to mean more. So, or is going to be more. We're going to find out and is going to be less. So, or being more means that the one that has more on it will be our answer. Our final answer, since it's everything up here, the top one actually includes everything. -5 going to the right. We'll include everything, and I'll have to write my answer, h, where h is greater than -5. So everything in that top one actually included the second one, and that's why my final answer looks just like my top one. Let's look at the difference between that when it's an or problem and an and problem, if it's going in the same direction. So if it's x is greater than 1 or x is greater than 3, we have greater than 1, we have greater than 3. Or is more. Or is everything, but it always turns out that or is more when it's going in the same direction. So which graph has more shaded when you're looking at it? The top one. So it's greater than 1. And your answer would be x, where x is greater than 1. As opposed to an and problem. If it was x is greater than 1 and x is greater than 3, we have the same two graphs, 0, 1, open circle to the right, 0, 3, open circle to the right. But remember, and means just where do they overlap, which is always the one that looks like less when they're going in the same direction. So that would be the bottom one. So 0, 3, open circle to the right. For this and problem, the answer would be x, where x is greater than 3. There's two more odd things that could happen. When you have a problem, and let's start with an and one. If it's x is greater than 2 and x is less than -1. So if this one is the word and, let's look at what we have. Greater than 2, less than -1. And is always where do they overlap? In this case, they're not overlapping at all. There are no numbers that are being graphed in both of these. So therefore, this one has no solution. And your final number line would just be blank. Nothing would be shaded. So that will only happen with an and problem when they don't overlap. There's something else that could happen with an or problem when I have x is greater than -1 or x is less than 2. So greater than -1 looks like this. Less than 2 looks like this. So it's an or problem and I need to have everything from the top graph plus everything from the bottom graph on my final, the second graph on my final graph. They're going in different directions, and they're overlapping, and it's an OR problem. If I was to put everything from the top one, everything from this one, my answer would be everything on the number line. The whole number line would be shaded in. So you just do a solid number line, don't put anything else on it, and your answer would be all numbers. All numbers would work. Everything from the first graph and the second graph is going to give me all numbers.